So students, today in this video I'll discuss about the Viva in the physics practical examination, and also I'll share with you the my experience as a internal examiner. Today also in our school we conducted the your practical examination, physics practical examination. So what are the expected questions generally the external asks? So your topic wise, the let me explain some of the that expected questions, so that it may help, it may be helpful for your physics practical examination, and you may answer to the external, so that you can get also the full marks, because generally we try to give our try to give means more than 26 27 to all the students. But in case you have not updated the your notebook, your activity file, your project file, then it is very difficult, or the whatever the experiments that are asked, the table or the graph or the circuit diagram, whatever is there, if you will not write properly the CBSE examination, your papers also, then because the exam papers you have to send to the CBSE, right? If you will not write properly, it's very difficult to for the external also or the internal, because it will be difficult for them to give you the marks, because we don't want to deduct the marks, because in this practical examination we expect that students should score more than 26 27, or let's say 28, or maybe 29 or 30, right? So within this range we want to keep everybody, but sometimes we have to give less marks also. So if out of 30 you are scoring 30, so it's a bonus for you, right? In theory paper, out of 70, if you are scoring 65 also, your score will be 95 plus easily, right? So there are high chances that in theory you may make some mistakes, 1-2 marks may be deducted. So that's why to score 95 plus, it's very important that your physics practical must be approx more than 28 or 29 or 30 it should be, right? So you should plan accordingly. So let us discuss some of the Viva questions that may be asked in your examination. So this year you have to complete you have to perform one experiment from section A, one experiment from section B, and one activity. These three things you have to write in your paper, right? So one experiment, let's say 6 or 7 experiments are there in section A, so out of that one experiment you have to write in uh, you have to write in the exam. So your let's say from section A, what are the experiments? Most of the schools, what I know, or what we discuss with our colleagues, so that we came to know that most of the schools uh, are having this, means they have done this type of these experiments because they are comparatively easy, not we can say that it's fully easy. The first experiment most of the schools have done, that is the resistivity of 2-3 wires, right? This is the first experiment. Second one is to find the unknown resistance of a meter bridge. Unknown resistance of unknown resistor. Find the value of unknown resistor using meter bridge. The first one is find the resistivity of 2-3 wires. Resistivity of 2-3 wires, right? By plotting the graph between U and V, plotting the graph between V and I, plotting the graph between V and I, right? Resistivity you have to find. So these are the two experiments. Third one also most of the schools have done, because third one is also the meter bridge application, right? So third one is verify series combination. You have to verify the series combination. So series or parallel, right? So these are the three experiments, and fourth one, some of the schools from section A they have done galvanometer, right? Some of the schools, very few schools, I think sonometer one they have done. Most of them have done the galvanometer half deflection method, either to finding out the galvanometer resistance and the figure of merit, and some of the schools they have done about conversion of a galvanometer to ammeter or voltmeter, like that. So what can be the expected Viva questions from these four experiments, right? Most of the external, what they do, they ask at least to show one reading, right? They ask the students, or they go to the students who are doing the experiments, right? That show me that how you are doing the experiment, show me the connections, show me or tell me how, show me one calculations, right? Show me one observation. So you have to connect the circuit and you have to tell, sir, this way I have connected. So you should know the connection basically, and better is means if you know what are the experiments you are going to have, at least 3-4 selection if you are getting, that's good. Means if your teachers are giving, or if out of 8 or 9 experiment you have to suddenly do 1 or 2 experiments, so in that case you have to keep in mind all the experiments. But for Viva, the experiments you are doing, generally the external asks most of the questions from that two experiments, but he also while he checks the record book, he also asks the questions from your all the experiments that you have done, and also he asks the questions about from your project file. He asks the questions from your activities that you have done, right? 6 activities you might have, you should write in a notebook, and at least one activity you have to perform during your exam, or you have to write, right? So these are the 4 experiment. The galvanometer one was the 4th one, most of the schools that they have done. So what kind of Viva what kind of questions can we ask from this resistivity of 2-3 wires using VI? VI, you are by plotting the graph between potential difference and current. So you know that rho equal to R A upon L, right? That you know that R is proportional to, you know that R is proportional to length, inversely proportional to 1 upon A, and R equal to rho L by A. Some of the external can ask, so what is resistivity, or what is the relationship between the length of the conductor? If the length of the conductor will increase, what will happen to the resistance? You know the basic things, right? If the area of cross section of the conductor will increase, what will happen to the resistance, right? Resistance will decrease, and resistivity is the, what is the unit of resistivity? This type of questions can be asked. What is the requirement of the graph here? From the graph, how will you calculate the resistivity, or what is the requirement of this graph, right? So you can say that the VI graph, from the VI graph, what you will calculate here? From the VI graph, actually your VI graph you will calculate. So VI graph will be a straight line, because from Ohm's law V is V proportional to I, or V equal to IR. So VI graph will be a straight line. So straight line means from what you will get. So R will be basically delta V by delta I. That means it's a slope of the. So you can join, this one is your delta V, this is your delta I. So you can choose one point and you can find out from delta V by delta I. From the graph you can find out the resistance of the wire. Given wire that is given, you have to find out the resistance. But the M is not resistance, M is the resistivity. So for resistivity, you cross multiply, that is RA upon L, right? So if you should, the given wire, you should know the length of the wire L, and A is the area of cross section that you can measure using it. So external can ask, how will you measure this area? How will you measure this area? So area, you know, area, because a wire is given to you, how will you measure its area? Area means this type of cross section. So to measure the area, you will basically use the screw gauge to find out the diameter. To find out the diameter of this wire. So if you get the diameter, you can find out it's a circular one, so you can find out pi d by 2 pi r square. This way you can find out the area. So you can find out the area this way. Length we can measure with a scale, the length of the wire, and r will find out from the graph. The delta V by delta I will give us the resistance. So using all these things we can find out the resistivity of the wire. Right. So this type of questions that can be asked, right? Resistivity of the metals, non-metals, right? How they are dependent, or he can also ask you questions like that resistance, right? Resistance of different material, how they are dependent, or how resistivity is dependent upon the temperature, right? So this type of questions he can ask. Also sometimes basic questions like Ohm's law, or these things also can be asked from your first experiment. The second experiment is about the unknown resistance in a meter bridge. So see, second or third if you are doing, so common question may be there, because both will be using the meter bridge apparatus. So meter bridge, you know that there will be a 100-meter scale wire, and it will be connected with one unknown resistance, one side left gap or right gap, another side resistance box will be there, right? So this is your resistance box will be connected to one side, and another gap will be connected with a unknown resistance, and here 1 meter long wire will be there, and here one scale will be there, right? And from the middle point the galvanometer will be connected, and here you will connect with the jockey. Now there will be, so the scale will be there, so you will put this jockey over the wire, and you will see the minimum deflection in the galvanometer, right? So when the minimum deflection will be there, suppose this position, you will note down the length. Suppose this length L1 is 40, and L2 will be 100 minus 40, that will be basically 60. So this is your suppose unknown resistance that you are supposed to find, or here resistance box you will get a known resistance. Let's say this is 4000 ohm. Whatever the knob you will take it out, it will be the resistance. So like that, what you will do, he may ask lots of questions. How means, what is the applications of this meter bridge? Which law or we are using in this meter bridge? So here we are using basically Wheatstone bridge, right? We are using the condition of the Wheatstone bridge condition, that when the no deflection will be there, or no current will flow through here, through this galvanometer, Ig will be 0 in this condition, R1 the ratios are equal, right? So we are using this principle. Which principle is used in this case, he may ask many times. He can ask you to draw a Wheatstone bridge, circuit diagram of a Wheatstone bridge. So you can write R1 by R2 equal to R3 by R4, and we are getting this for Ig0, no deflection. Okay, so that's why we are finding no deflection, and when there will be no deflection, this ratio will be equal, and from here we can find out the unknown resistance. So you can explain like this, right? It is a general question. Generally for 2 and 3 he can ask you like this, right? So also he can ask, if the time will permit, he can ask that solve it, right? Solve it and solve this relationship, how it is coming up. You can use the Kirchhoff's law and you can solve it within 2 minutes. You can get this relationship. Also he can ask you that what is the use of resistance box, or how you are taking the reading for resistance box. So many questions can be formed using this, right? We are using left side and right side. If I'll exchange the position, this resistor here, resistance box here, what will happen, right? So basically this null point, the zero deflection point will shift. It will adjust such that your unknown resistance value will remain constant, right? So this type of questions he may ask you from this both this and both this 2 and 3. You can also ask how series combination you can verify. So we will say that, sir, first we will use one resistance, then we will use two resistance in series, and we will see that when we are using two resistance in series, the value is same as the individual resistance. We are getting the value of the resistance. When we are summing up, adding all, both the value, we are getting the same, approximately same when we are connecting them in series. So hence we are getting proof that the sum of two resist means sum of the resistances when the two resistors are connected in series is the just sum of their resistance value. So like this he can ask you questions like galvanometer. Also you can plan how galvanometer deflection is taking place, how can you convert, what is the use of the shunt resistance, right? So one resistance will be connected parallelly with the galvanometer, right? So he can ask you all these question, right? Galvanometer deflection. He can ask you that if what is the principle electromagnetic induction, or what is the principle inside this galvanometer, how galvanometer is deflecting, right? How galvanometer is deflecting. So inside a radial magnet some coil is there, and it is deflecting when the current is flowing. It is also creating the magnetic field, so it is rotating, right? More current will flow, more magnetic field, so more it will rotate, more deflection will be there. And what is galvanometer? What is it, how it is different from voltmeter? How galvanometer is different from voltmeter? So this type of question he can ask. Galvanometer, you can check the direction of the current. It both way it can this your pointer can move, right? It can move towards right if the current is flowing like this. If the current is flowing this side, it can the pointer can go this side also. But voltmeter or your ammeter, so ammeter, the current if it will go like this, so it will deflect towards one direction. It cannot deflect to both the direction. So right, can you, how can you convert this one to voltmeter, how can you convert to ammeter? So this type of questions you can go through. So these are the questions for the Viva examination. Now we will go to the section B. Though the video is getting little bit longer, I think in one video I should complete all your expected Viva questions for section A and section B. So now let us go to the section B. Let me quickly at least tell you some of the questions so that it may helpful to you, and you can get an outline that what can be asked in the examination, right? So in the section B, the most of the schools are done, means they have done about the experiment with the light, that is to find out the focal length, right? So first two experiments maybe some of the schools might have done to find out the focal length of concave mirror. Some of the schools might have done to the convex lens one, using the graph 1 by u and 1 by v, or 1 by u and v graph, right? During the graph between. Third one, most of the schools I think have done about the refractive index using of the refractive index of the glass slab using the your traveling microscope, right? So refractive index using traveling microscope. Then fourth one, some of the schools might have done using the liquid plane convex lens. That one some of the schools done. Many of the schools have done about PN junction diode. PN junction characteristics, curve, forward bias and reverse bias case, right? So forward bias and reverse bias case, PN junction diode, PN junction diode. This one most of the schools have done. And so concave mirror focal length, right? Some of the external, if you are doing any of these experiments, some of the light experiments especially, the external may ask you to adjust and show you the readings, and if not, he may ask you, suppose the first one, to find out the focal length of a concave mirror using find by finding out the U and V, right? So just this is the optical bench, your mirror will be there, concave mirror will be there, and your pointer will be there, right? So that you will find out U, you will find out V, right? You will find out V, and you can here yeah, somewhere here you can find out V also. So using like that you can find. So using your optical bench, you will find out the U and V, you will note down, and you know that 1 by V minus 1 by U equal to 1 by F. So using this relationship you can find out the focal length, right? He may ask you a lot of questions like if you know the basics of your light chapter from class 10, you are studying this, so you know the basics, right? Both the first and second, he may ask you some of the common question: when the real image will form, what is the nature of the image, when the object will be at a 2f, concave mirror, suppose this is convex lens, from the graph how will you calculate? So 1 by U and 1 by V, this is, let's say 1 by V, this is 1 by U. So the graph if you will draw, it will be a straight line basically, right? So from this graph how will you calculate the focal length? He may ask you from the for the question number 2, that if it is 1 by V, this intersection point 1 by U will be 0. So using lens formula, 1 by V minus 1 by U equal to 1 by F, here 1 by U equal to 0, so 1 by V equal to 1 by F, and F will be this distance, 1 by this distance. So you can say from the graph you can calculate like this, or you are doing 1 by U and V graph, then also you can draw a 45 degree, and this one will be 2f point, and you can also find out the focal length. So the questions he may ask for both this experiment to find out, or he may ask you the formula even. Here mirror formula, here lens formula. He may ask you simple questions like the concave and convex mirror, what are the mirror formula, do they use the same formula or the different formula? He may ask you the sign convention, if the object is in the left side, then whether you will use a negative sign or positive sign. He may ask you that what is a real image, what is a virtual image, what is a magnified image, what is a diminished image. So different cases he may ask you. He may ask you about suppose convex lens, power of a convex lens. Convex lens can be used as a simple microscope. So this type of questions he may ask you using this lens. Then the third one is refractive index. Again it's from light chapter. Yeah, some of the schools also have done about prism one also. Prism one also, minimum deviation, prism experiment also many schools have done. So refractive index using traveling microscope. This one also you can he can ask you that what is refractive index, what is Snell's law. He can ask you how you are using the formula of real depth and apparent depth formula here in to find out the refractive index, right? What is the refractive index of glass, what is the refractive index of water? Some of the basic refractive index you should know, like glass refractive, because here we are finding out the refractive index of glass slab generally. So glass slab refractive index, that means it's made up of glass. So glass slab refractive index, it should be approximately 1.5. He may ask you, can you say the refractive index of water? You can say 1.33 approx. Right. He can ask you what is Snell's law. Refractive index is sin I by sin R. Right. He may ask you the basic principle of refraction. Right. That when the light will incident on from a rare medium to denser medium, what will happen? The ray will be away or it will bend towards the normal, right? So if it is rarer to denser, you know that it will bend towards the normal. So you can say all these answers if the questions are asked from this refractive index one. PN junction one also, you know that it's a forward bias and reverse bias. He can ask you to make the circuit diagrams, right? Here also he can ask you to draw the ray diagrams. If the object is a 2F, draw a ray diagram to form the for the formation of the image on for the formation of the image, right? So if the object is a 2F, image will be also 2F for convex lens, and so you can plan or prepare for this type of questions. So PN junction, let us come to the PN junction part. PN junction, you know that the circuit diagram is, he can ask you the forward bias, reverse bias, what is a semiconductor, all these things he can ask, right? What is a diode? So PN junction, how p sides are, what is a n type semiconductor, what is a p type semiconductor, he can ask you also. So this is p side, this is n side. For forward bias, how will you connect p side, is because many students have opt for this experiment, because here no calculation is there, only you have to draw the graph, but yes, the graph should be proper. So PN junction, if the positive side of the battery is connected to p part and negative side is connected to n part, then we can say forward bias, and the graph will look like for a low voltage, means approx 0 to 3 volt or up to 10 volt, if we provide, you can get a current in the order of milliampere, and the graph will be like this, slowly increase, then after a point it will rapidly increase, right? So the graph will look like this. So similarly for reverse bias, it will be, let's say PN junction diode. So the p side will be connected to the negative and positive terminal will be connected to n side, the reverse one, and here across this one you will connect a voltmeter, and also you can connect a ammeter in the series. So this circuit diagram he can ask, here also circuit diagram, the voltmeter you will connect parallelly and ammeter in the series you can connect. So circuit diagram he can ask to draw the graph, and he can ask you what is the reverse bias case. It will be ordered on the microampere. Why less current is coming in the reverse bias case, right? You know that negative, if positive is connected to negative and negative is connected to positive, there will be a depletion region. The electrons will not flow continuously, it will be deflation region will be created, that's why the low current will flow, right? Off condition generally we use this one. Forward bias is a on condition, so here the electron will the electron will move towards the positive side and so to the this one, so the flow will be continuous. So more current you are getting in the order of milliampere, here microampere, here also you will get like this. So there will be a breakdown point like this in the, this is reverse bias, this is reverse bias, this is forward bias, this is forward bias case. So this type of question he can ask you in this PN junction, prism also, if you have done prism also, you can see it means minimum angle of minimum deviation. What is angle of minimum deviation, he can ask you, right? If the incident ray, what is emergent ray, right? So he can ask you all these this is angle of deviation. He can ask you the formula, he can ask the graph, he can ask. So all these things he can ask from a prism, right? If white light will be there, how you are getting the spectrums of the colors, right? And when the colors are having different wavelengths, which color is bending less, which color is bending more. So this will be red, this will be violet, violet is bending more, red is bending less, right? So all these things he can ask you from the prism experiment also. So you can plan accordingly. You can go through the your manual, lab manual if you have, and also you can go through the book, so that some theory also you can learn, right? So that you can confidently answer to the external, and out of 30 you can definitely you can score 30. So I hope this outlines of the Viva will be helpful to you, will give you a confidence, and also some of the questions, basic questions that generally every external asks, definitely some of the questions you will also get if you are having these experiments in your um, list, or you are going to perform any of the experiment. Definitely whatever the questions I told, some of the questions definitely you may get, right? Practice ray diagram, circuit diagrams, all these things, and all the best for your remaining practical examination. Those students who are having, it's fine, already completed, it's fine. Those who are yet to have the practical examination, all the best. So go through it, score full marks, and then start preparation for your board exam, theory exam, so that combiningly you will get a good score and full score, maybe target more than 95 plus this year. So thank you for watching. See you in the see you another video. uh, Thank you.